All right, I want to do question 2 from the homework. Some interesting conceptual things going on in this question. So it wants us to look at the product from exercise 1, where we have supply and demand functions given by this. So again, I think this must be our demand function. Oops. This must be our demand function because it's decreasing. Right? Remember, demand functions always must be decreasing. This must be the supply because it always increases. But it always increases on its domain of Q being greater than 0 anyway. All right, P is in dollars, Q is the number of items for supply and for demand. Okay, cool. So again, in 1A, you probably answered which one is demand, equilibrium price, all that stuff. So again, suppose the price is set artificially to $70, which is above equilibrium price. So we're going to start by finding the quantity supplied and the quantity demanded. Well, just plug in the function. All right, the demand is going to be price is 70, demand is 150, minus 0.5 Q. We can solve for that. We get 0.5 Q equals 80, or Q is 160 units. Similarly, we can get the supply. 70 is going to be 0.002 Q squared plus 1.5. This one will be a little bit more complicated to solve, but not too bad. Subtract the 1.5 over, we get 88.5 equals 0.002 Q squared. Multiply both sides by 500. Oh, I can't do that in my head. All right, so we'll use a calculator. And say 88.5. Why can I not see you? There you are. Divided by 0.002. You get 44,250. And then we'll take the square root of both sides. Square root of 44,250 is about 210.36. About 210. Okay. So again, at a higher price, remember what supply and demand curves look like. Supply curve here, parabola. The demand curve here is a line. So after the equilibrium point, again, this is supply. This is demand. After the equilibrium point, supply should be higher. And you can see that supply is indeed higher than the demand to the right of this. Okay. So using the quantity demanded at 160 units, find the consumer surplus. So the consumer surplus, remember, was the integral from 0 up to demand. No. So using the quantity demanded, find the consumer surplus. And we're comparing it. We're essentially going to be comparing it to our answer from 1C, which, yeah, it's going to be a smaller number. I didn't want to actually do number 1, but we're going to have to do number 1 to compare it. But anyway, it's going to be the 0 at this price, consumer surplus. Sorry, at this consumer surplus is for demand. Going to go up to 160 units here. Actually a little nervous that I made a mistake with my supply. It really is 1.5 though, right? Let me know if you see a mistake. This almost looks like it should be a perfect square, but I guess it's not. Did I type it in right? Square root of 44,250. Yeah, all right, who knows? It's going to be demand, which is 150 minus 0.5 Q minus P star Q star. And P star Q star you found in part 1, which I guess I kind of have to do part 1. I was hoping I didn't have to do so much in part 1. But in part 1, demand is P was 150 minus 0.5 Q. And supply was P equals 0.002 Q squared plus 1.5. And we can visualize that. So to get the equilibrium price, supply Q star was 175 items approximately. And P star was 6260. Okay. So Q star times P star is 175 times 6260 approximately. So that consumer surplus, we type it all out, is as follows. The integral from 0 to 160 of 150 minus 0.5 Q minus 175 times 62.60. Consumer surplus is 66.45. Which should be a smaller consumer surplus than what you had before. Because again, this equilibrium price was 62.60. So remember what this is all about. Consumer surplus is the area under demand over here. But as soon as we cross that equilibrium point, this area becomes negative. So that's why our consumer surplus is going to be smaller. Consumers are saving less money over there. Okay, and that's what it wants you to compare to. And again, you could calculate very quickly at the your answer from part A was with the equilibrium quantity of 175. And you could see that here, right, 76,100 is more. All right, so you can see, yep, our consumer surplus has gone down in number 2 compared to what it was in number 1. And similarly, the producer surplus integral from 0 to 210. Again, it wants us to use the quantity demanded. 0 to 210 of our supply equation, which is 0.002 Q squared plus 1.5. And we're taking P star, Q star, and subtracting. Forgot to subtract. All right, because remember they have opposite orders. So P star, Q star, 6260 times 175 minus the integral from 0 to our new demand for suppliers, which is 210 times 0.02 Q squared plus 1.5, was it? Yep. PQ, and again, the producer surplus here is 4466. Which again should be a smaller producer surplus than there was at the equilibrium price. All right, equilibrium price or equilibrium quantity was 175. And oh gosh, that was not what I wanted to do. 75 up here. Yep, it was bigger. And the way that makes sense is remember that producer surplus is all this area. But as soon as we go to the right of this equilibrium point, we now have like the opposite kind of area. So it's getting smaller now. What's going on here? And that's kind of what I wanted to include this video. I wanted to talk about it. So we did this B and C total gains. Again, we add those two together. It'll be smaller than the total gains from the first example. And E, what do we observe? Exactly what we said. Okay, we've observed that, yeah, when we're further along than the equilibrium price, our consumer and producer surpluses and total gains are going to be smaller. That's basically it. Let me know if you have questions about this one, and have a good one. Bye-bye.